Hey, 8th grade. Today we're going to talk about exo and endothermic reactions, and we're going to start doing this with an experiment when you come up to the front. But let's start with talking about what our big questions are, and that is, what role does heat play in chemical reactions? What are the parts of a chemical reaction? How do chemical reactions affect the mass of the substances involved in it? How can we speed up a reaction? How can we slow down? And how can we describe heat reactions? And that last one is our main player for today. We've been talking about a bunch of these over the course of the last week or two. So when you think of the word thermic, I want you to think of the word heat. Any reaction labeled with thermic deals with heat, which is your energy input. And there's two different types that we're going to talk about: exothermic and endothermic. So if we're to look at these two graphs, these both show the exothermic and endothermic reactions. And you have your starting products, and you have this energy or this heat. And then you have to have this energy being input in order to reach this peak so that you can get to your products. So just like over here where you need this great amount of energy for this endothermic reaction, in an exothermic reaction, you have your starting products. You need some energy in order to get to your products. But everything needs this energy going in. So when we talk about exothermic, we're talking about heat is being released from the particles into the solution. So the heat exits because it's exothermic. And the solution becomes warmer. So exothermic reactions have a solution that is extremely hot. So exo, extremely hot because heat exits. Exo, exit. The next, I want you to look at this graph real quick. And this is that same idea, but just talking about that exothermic reaction. So across the bottom, we have this increasing energy, across the y-axis, we have an increasing energy, and on the x, we have this reaction progress. And you start with these reactants, which are your ingredients going in, and you need this activation energy or this little bit of energy to get over the hump in order to get down towards your products. So this little bit of activation energy shows what it takes to get this reaction started. And then once you have started, you'll notice that as you go towards the products, this energy decreases because, like we said before, the heat is being released, and that heat is your energy. So as that energy is released, that's why you see this downward to the product sitting here at the bottom. When we talk about an endothermic, we're talking about heat being absorbed into particles from the solution. So the solution actually gets colder. So the heat enters, or endo enters, E-N-E-N. And when you think of this endothermic, I want you to think of it being really, really cold. And if we were to look at a graph of this, what we see is that, just like we said, this energy is being absorbed. So the reactants start with this really low energy. And then in order to get to the products, we have this great, great, great amount of energy that has to be input or absorbed in, creating that cooler solution, and then our products up here. So when we talk about the rate of reaction, we're talking about how quickly a reaction occurs. And this is what we had talked about yesterday. And there's many factors that actually influence these reaction rates. And some of those things that influence it are the particle size. If it's a large one, it has a slower reaction rate. Smaller particles, like a powder, have a faster reaction rate. Hotter temperatures have a faster reaction rate. And cooler temperatures have a slower reaction rate. So go ahead and think back to that thing we did with the tablets and the water. And we did both the small and the large particle size versus the hot and cold water. And so all of these factors, as well as some other ones, can actually influence the rate of these reactions. Once you're done with this, if you have some time before transitioning to another station, you may be on Quizlet practicing your chemistry vocab.